So the context is that this is part of the Advanced Incident Handling course. All week of those 5 days of that course, we deal with one event that changes and becomes more complicated as it goes on. And the people who are taking the class are part of an incident response team who are doing stuff. So what I've just done is I've given you the malware analysis module, which is followed by an exercise, and this is the exercise. So what's happened is there's been a break-in in this company, and these files have been left behind by the intruder. So your job in that exercise is you are the malware analysis team. And so your job is to understand the files, to use the commands we talked about, and to analyze this malware so that you can give a report to the incident handling team to give them clues on what to do next, okay? That makes sense. That makes sense? Makes sense to me. So this is a list of the files that you are given. This is a simple Unix, and this is a Unix-based exercise. Don't get hung up on that, because you still have investigative questions that you would ask about the files, even if you don't know the specific command. And that's what I try to impress upon them. Think about what do you want to know, and then and the way this exercise works is the instructors are the computers. You say, please tell me what's in this file. I want to know, first of all, can I print this file? And if I can print this file, tell me what's in it. And we as instructors say, here's a description of what's in the file. And they say, oh, it's ASCII. Print it for me. And we hand them another piece of paper. Okay, so that's how this goes. Now what this means is this style of teaching you can take anywhere because it's all paper-based. So this is what you start with, a list of these files. So do any of them, I mean, they're files. You don't know anything about them except their names. You know what their extensions are, but you also know that their extensions don't mean anything. So what kinds of things would you do next? Don't get hung up on the Unix part.
File for signature.
That's the kind of thing you do. And what I'm going to do, since I don't have them in order, is I'm going to actually go in this order. And that is where you say, give me everything about the files. Before, you just saw the file names, and now you see something else. Is there anything that you notice there that catches your eye about this list of files? I keep standing in your way, I'm sorry. Well, router, why is that of interest to you? Because of the root permissions, which is the all-powerful user on a Unix system. You notice when you compare password, what is a file name password? It's the traditional password file that shows up on a Unix system. Now notice here, when you compare these two screens, there look like there are 1, 2, 3, 4, 5, 6, 7, 8, 9 files listed there. But when you go to the next screen, you see based on the number of lines, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 files. So
root directories and hidden.
So these two are normal parts of this. So that takes 13 down to 11. This file is essentially a hidden file because in Unix it starts with a dot. So that takes 11 down to 10, but we had 9.
Yeah, that first
first
line
one's
has
probably
no file name.
Oh, it has no file name. Well, isn't that interesting? What it actually has is it has spaces as its file name. So that when you do a listing like this, and this is one of the things that, one of the challenges for the students, is you don't see a file name that has just spaces. The reality is you do, but you don't recognize that that's the name. And one of the things you need to know about Unix systems is Unix systems, you know when Unix was started? 1969. Unix was started when the Multics project ended at MIT, which was Multics was AT&T, Bell Labs, and MIT. The money was pulled. The people at Bell Labs said, we're going to do our own system, multi, uni, X, and X. So Unix is a play on Multics. That's where the name comes from. So think of the state of computer technology in 1969. What was the input device?
The card.
Not, it might have been postcards. You know what a KSR-33 is? It's the keyboard and the paper tape runch. Yeah, teletype. Okay, slow input and output. And what that means from a Unix perspective is the commands are very terse. If they don't have to say anything, they don't. So the point of that is it wouldn't put a blank line in there normally, because that's not a Unix thing. So that means the file name has blanks in it, because you as a normal person looking for that wouldn't even say, there's just a blank line there. That doesn't mean anything. Okay, that's my point. So that is a variant of a hidden file. When you do an ls-la, you're saying give me all the files, including the files that begin with dot. Give me a long listing that gives me the type of file, who the owner is, the size, and a timestamp. And so that gives you these 3 dot files. So this file here that's got blanks in it is a regular file that's 905 bytes long that has no name. Well, that has no printable name with normal characters. So what happens next? So now let me look at that file that contains 2 spaces in it, and I see a bunch of things.
It's like
So what's your interpretation of that file? It's got a bunch of host names, and it's got a bunch of accounts. And what this file represents is a listing of the file that, in fact, you're right, Rooter owns. So this is a list of all the files that have been compromised by this user. Now here's a couple of funny ones down here towards the bottom. What kind of systems do these appear to be?
Windows 95.
Have any idea what that means? Within the context of remotely controlling computer systems.
It's little back doors. Back orifice.
Back orifice, very good. So these 2 machines, whose host names are this, are Windows 95, which has no logins and passwords, are controlled with back orifice. Okay, so this is the intruder has hidden this file because it's got spaces in the names. You'd never look at it. Okay, so that's what that is. So here is what. First of all, do you know what this file is? Do you know what bash is?
History of the Born again shell.
Correct. That's the shell, named after Steve Bourne, who worked at Bell Labs. Hence the name Born Again, because it's spelled B-O-U-R-N-E, as in the Bourne identity. It's a coincidence. So it's the Born Again shell, and that contains the history of all the commands executed in this account. Okay, do you know Unix commands? What is the PS command?
process.
So why would an intruder run that?
I know what's running.
Tell me what's running. What's the next command?
Who's on system?
Who's logged in? What's the next command?
Directory.
Yeah, tell me what files I am. What does this command do?
Transferring a file.
And so he's FTPing to this, and what can you conclude he FTP'd? What file did he download?
The right file.
Stuff.tar.gz. Okay, so that's a zipped file using the tape archiver. So when you gunzip it, you unzip it, you end up with stuff.tar. The tar command that says extract verbosely, giving me a listing of what you've extracted from this tar archive. And then he does what? And then what does this do?
Removes the file.
And does that correspond to what we saw in the archives that were left? Did you see the
Yes, I did see
stuff.tar?
stuff.tar.
Okay, so where would you find that if you were doing a forensic analysis? Unallocated or slack space. You may get lucky and find that file, which would give you more data to say, he did remove it and I found it. What is this command doing? Okay, he's running the compiler. And then what does this mean?
Running currents.
He's running the copy that he just compiled. And then what is he doing?
Editing.
Hey,
and then he's,
Running
Pipe.
it again.
and then he's,
Right.
Running it again.
and then he's,
And then again. Wow.
and then he stopped.
Work.
Right?
He got it right. Okay? And how would we know that he got it wrong? What does a program under Unix do when things go badly? And what is the name of the file that it creates?
More.
A file named core. So what would you expect the core file to be?
That's
No,
your
we
source
don't.
code. That's your source code in the assembly.
Well, it's a binary file that contains the program that dumped core. So it would be similar to the Furby program, except it's a core image. And you could actually do some analysis of that core file and say, by the way, where did you come from? So what happens is, exactly what you said. He compiled it, he ran it, it didn't go well. Is that where the core image came from?
No.
He edited it, he compiled it, he ran it again, and it didn't go well, so that produced a core image that overwrote the first core image created up here. Then he Emacsed it again, compiled it again, then it worked correctly. Now essentially what this, well, I won't get into that yet.
That should be a second iteration, the core, the second iteration.
Well, except it doesn't work that way. It overwrote the previous instance of the file named core, threw it away and rewrote it. So if you had a version and control system built in the file systems, you'd see two cores. That doesn't happen here.
No, I
So
mean,
that-
the one that's left, though, is the second iteration.
Is correct. So then he does what?
He removes that.
And we didn't see that in the directory listing, so that makes sense. Then what does this program do?
Tell them who's logged in.
His user.
And who might he be logged in at that case? Root. So if he's doing what we think he's doing, and we're not sure yet, he's probably root at this point. So then he does an ls. This is a program that I think was included, and we can do a more detailed analysis. What is this program? Lynx is a command line browser. So if you're sitting in a terminal window and you do links to a URL, you can get a TTY and ASCII version of that website. So if you're not in a Windows system, it's a handy little tool. What does this program do? Less. Yeah, it gives you the back part. It's like more, and it's showing him a file. You know what Telnet does? Oh, and by the way, he's running this program, which we don't know what it does yet.
Background.
And what is he doing?
He's redirected to a file called ZZT.
But it's got two greater than signs. What
So
does
he's
that mean?
appending.
So he's appending onto the end of that. And then he's checking to see if it's found anything by saying, give me the end of what this file is. Make sense? Then he's checking it again, checking to see who's logged in. Then he's going to another machine. He's running another mscan routed to the same file. Now, is this a safe operation? The answer is maybe. Maybe it's safe, maybe it's not safe. He's writing onto the end of this file, and here he's writing onto the end of the same file. If both of these two programs are running at the same time, the results are unpredictable. You buy that? Okay. And he runs links again, who, PS, less, telnet. So he is in a domain called widgets.example. So where is the host www? It's in the local domain. So he's connecting to the host www in the local domain. The local domain in this case is widgets.example. He's doing a telnet to Tokyo, which happens to be a machine in Tokyo. Date. Oh, here he's Emacsing, and this is actually wrong. These should be forward quotes, not back quotes. That has very different meaning. So here he's he's editing that space file to add something. Now he's editing, he's root, right?
Yeah.
So he can edit the real live password file as root, and he'll be able to do whatever he wants to do. Yeah.
Did I miss, how did you determine how many spaces were in the name of the file?
What I can do here is I really can say, this lines up under this.
No.
This-
Originally, when you looked at the file listing, how could
He
you tell?
created the file.
That would be hard to do. What you could actually do is do an ls pipe to OD-C octal dump and get a character dump and see that there were 2 spaces.
Okay.
But yes, you could do it. From this listing, I can see that since this is a monospace font, that I can see this lines up with this lines up with the C, so there have to be 2 spaces in here. Okay. So then what he does is runs another M scan to ZZZ again, and then he exits. This exit is partnered with this instance of running the Furby, because this starts, we believe this writes up a root shell. So this exits out of root, and this exits out of this person's account, whatever account this was. So this is a chronological order, but it doesn't have any times of what this person did. And it's very nicely stored in the bash history file. So now, what you can do is you can build a timeline. At least you can build a sequence of events. You don't know what the times are necessarily. Clearly, the only timestamp is this. One of the timestamps is easy, but we don't know who's writing into that. And the only timestamp you get out of that would be the last one. You could get a clue about when these files were, when the files were compiled. Because when you compile a program, it creates a .o file, and then it runs the loader or the linker to take the .o file and convert it into binary. Then it deletes the .o file. So that .o file would be in deleted file space, and you might have all the attributes about it, like when it was last written. So that might help you do a timeline. Do you understand what I'm saying? Otherwise, you don't have too much information.
What about like commands like who is not that automatically? Like some of them, they get. You can see the log and see when it happens. On any, like by default on any Linux, like.
You can find out who is on when they logged in, and
But I think who is one of those commands which kind of almost automatically, unless you change it, would be logged in, like log would be, it would be in a log. You would be able to see it.
who is only going to show you who's logged in. Now, if you were running what is called process accounting,
You might be checking to see if anybody else is on the system that might know what he's doing.
like root,
Oh,
Yeah.
Yeah, he's one.
that's where you're sticking up your periscope to see
Yeah.
if there's anybody else
Anybody
around in the
watching.
area. Is anybody watching? Okay, so part of the other, then this gets in, so that's basically a blow-by-blow what happened. So then we're looking at the other files. What is this file? It's a what kind of a file?
Encrypted.
It's a PGP file, but is it a key or is it?
That's a message.
So it's something that is encrypted. And this, by the way, is Windows, Linux, Mac OS. Are all the same. Produce.asc file. So it's a file that is encrypted with somebody, okay, with something. And so what you'd like to be able to do is to decrypt it. What do you need to be able to decrypt a PGP encrypted file?
Key.
You need a key. Whose key?
Private.
Not necessarily the person that decrypted, the person for whom it's intended. And what key would have been used to encrypt this file? Their public key.
And then the
The one
person
who's
receiving
receiving
it.
is their public.
Correct. Correct. And so what would you need to decrypt it? The person who's receiving its private key. How do you know who that person is?
Set it up in advance.
Might be able to find out elsewhere.
So as it turns out, if you say to PGP, try to decrypt this, it says, this can only be read by a person with this key ID. What is this?
Personal identifier.
Yeah, it's the key ID, which is a 32-bit hexadecimal number of the recipient. And so what you have to do then is you take that hexadecimal number, look at my business card. Does my business card have a key ID on it? It should. It should have 2 key IDs. It should have like 1024 or 28 / followed by something else that looks like this. That's a key ID. So now you want to know, the next thing you want to know is, who owns this key ID? So I can then go off and say, do you know what a PGP key server is? That's a server that's sitting out on the network, pgp.mit.edu, for example, that knows that you register your keys with. So you go off to the PGP key server and says, who owns this key? And it comes back and says, this key is owned by Julio Martinez at this email address. Now, the reality is, I can put out a key that says, Bill Clinton, clinton@whitehouse.gov, and put it on the key server. Okay, so maybe it's good information, maybe it's not. So at this point, is there anything else you can do with this artifact? You don't have this private key. You're dead, right? There's nothing else you can do with this artifact. You've gone as far as you can. So let's go on to the next artifact. We know what the core file is. It says the core file appears to be produced by a program called MKRDY, which we have no idea what that is. So Furby appeared to call this program Make Ready, and it was Make Ready that dumped core. So here's a file named log. What does this look like?
Chat.
It's a chat log. And it looks like it's got some pretty good stuff in it.
Is this IRC?
I think so. This admin didn't have a clue, and so it's got a bunch of, it's conversations between the intruders talking about the kinds of things that they've done and what machines they've compromised. I think there's, hi guys, where have you all been this week? The usual, off-routing R00TIN, which seems to be connected with R00TER.tar.gz. So there seems to be a connection. And so he's breaking into systems. And this is the conversation for the person who probably broke into this system.
This is the log of the person computer, and it shows which different IRC channels he connected to and disconnected to.
So then what is an MSPX file by convention? It's one of these X files like XLSX, DocX, PPTX, XLSX. So it's one of these extended Microsoft files. They also all used to have 3-character extensions. Now they've got 4s. So this talks about vulnerabilities. And we don't know what its relevance is. So we saw in that bash history .bash history file reference to a program named mscan. So the next file we're going to analyze is mscan. We do a file on it, and we see that it's an executable. So does that mean we can cat it? No. Or we can look at it? So we got to do something to it. So what we do is we'll run strings on it. And son of a gun, there's a lot of strings in there that we can read. So it's not PAC, it's not otherwise obfuscated. So the most interesting part is down here, where the author has told you how to use it by putting in the usage information. So this is a program that scans for vulnerabilities. So it was previously used, he ran mscan, this domain, look for vulnerabilities. So he's scanning for systems he can break into. And where was he recording the output of that? In the file ZZZ. So here's a password file. Do you know the format of the password file on a Unix password file? First of all, the fields are separated by what? So what's the first field?
User.
What's the second field?
Encrypted password.
Third field?
The user ID.
User ID.
The group ID. The permission.
It's actually
It's
what's
just the
called the
name.
G-coast name, the finger name, yeah.
Okay.
This is what?
It's
Home
Home directory, and this is...
home.
Okay. So if we look through this, we see that there are 13 characters here. And the way that the old style Unix encryption worked was it would take an arbitrary string of characters and turn it into 13 characters of gibberish. And so to have a valid password, you have to have 13 characters in the field. And so if this account is locked because there's nothing you can type, it gives you a star. So therefore there's no valid password in this account, nobody can log in. Nobody can log in, nobody can log in. Wait a minute. What does that mean?
It's free. You can log in.
There's no password. So one of the things you wonder is, this is an account that has no password that starts up a shell. And so that can be what? Yeah, it can be a backdoor. I can always log into this system so that everything else looks fairly normal until we get down to here. And that's an account named with some password. Ooh, what does 0 mean? So that means when you log in as rooter, you own the system. And home root, bin sh, different root directory. So what this person has done is created an account and created a backdoor. And we saw that when he Emacs'd the password file.
But the backdoor, is it root?
No, the backdoor is LP. Because
What is
LP
LP?
doesn't require a password.
So that means he can get on the system and he can do his Furby thing again if he needs to get root privileges, if he ever, quote, loses them.
Yeah.
Because I would expect as a normal system administrator, you'd come through and say, no, I'm hosed. I'll just delete this. Well, he's got LP. He can come right back and do the same thing again and hose me again because I didn't get him completely out of the system. So we'll skip this information. Just using whois to find out who all the players are. So if you take that password file, have you ever used a program named Crack? Have you heard of Crack? What does it do? It takes a dictionary and it takes a password file and it attempts to encrypt all the words in the dictionary and see if they match any of the entries in the password file. Now, one of the key things about passwords under a Unix system is that in that 13-character field, I won't go back that far. In that 13-character field, the first 2 characters are what is called a salt, and the last 11 characters are an encrypted version of the password. So when I take an arbitrary word out of the dictionary, I then encrypt it with the salt, and I will get this 13-character scheme. So in other words, I can use the salt plus an arbitrary dictionary to do brute force, as you said, brute force cracking, and attempt to determine that. So what they did was they ran Crack on the password file, and they found that these 4 accounts have real simple passwords. And so one of the things they did is precisely what we talked about.
Going back to the salt, is it salt, those 2 characters, are they always the same? I've never done that.
No.
So how do you determine when you're going to salt something, what the...
When I change my password, a random salt is created.
Yeah.
And then that salt plus my clear text password gives me the 13 characters, where the salt is the first 2 of those 13 characters. So I've embedded the salt in the password.
And it's always the first 2 characters?
Yeah. So let's see what happens next. So then there are 2 password files that are provided in the system if you look in this kit. One of them shows, in fact, that the password in LP has been removed. The other one shows that the rooter, which you already figured out, had been added to it. And the command to do that, one of the other things we need to know about Unix systems is Unix systems were built in 1969 by Bell Laboratories to support the patent attorneys at Bell Laboratories. And as such, they are text-oriented tools, like the diff command, which is shown here. Tell me the differences between 2 ASCII files. There's many, many, many programs in Unix that deal with text-based files for doing processing of them. And they're very handy tools to do that kind of comparative analysis. So now let's look at the Furby file. Furby was compiled, didn't work, compiled, didn't work, compiled, then it did work, and once it worked, he removed the source code. So all we have is the binary that's left over. So we look at that binary and see that it's in fact a binary. So what does that mean we do on it? We run strings on it. So if we ran strings on it, we'd see these things. And one of the things we see is a string saying, make ready. And then here comes root. So if you had to guess, you'd guess that make ready has a vulnerability in it, and make ready runs as root. And so that's what the vulnerability that he's exploiting. That's what it looks like. So then let's see if we can find out a little further down here. Here's the man page. Do you know what a man page is in Unix? It's the documentation. So here's the man page for make ready. Da-da-da-da-da-da-da-da-da-da-da. It must be installed with root privileges. So what it looks like is that there's a vulnerability, and in addition, it's a buffer overflow vulnerability that allows a local user to become root. And so he's found all the systems with his MScan that have vulnerabilities. This is one of the systems he found. He landed on it. He then exploited the vulnerability and became rooting on the system. And he left behind these telltale signs. Well, let's see what else is in here. And where was he keeping the MScan output? So let's look at the ZZZ file. So then you look at the ZZZ file, and it looks like it's got, what's this? Has a vulnerability, and it runs, what is the CGI bin? Do you recognize what that is? Within a web server, it's the CGI is something, common graphics interface, binary files that are run by the web server. So it's got a test program in there. It's vulnerable. It has the PHF vulnerability. So this gives a list of all of the machines and what their specific vulnerabilities are that MScan looks at. Okay? So what you could do as a member of the widgets incident response team is to process this file, because this file has 2,829 lines in it, and find out where all of the vulnerabilities are in your organization. And so the next several slides actually look at that. They summarize the vulnerabilities by IP address, vulnerabilities within widgets domain. So there are 815 vulnerabilities in the domain that you're part of in your company that this person has found. And so if you're an incident responder, you've got a lot of people to talk to and say, whoa, you're vulnerable, we got a problem. So that's the whole point of this. So it seems this starts out as a very innocuous, very small vulnerability, and then it mushrooms and mushrooms and mushrooms, and you can see from the contents of this file that there's many systems that are vulnerable beyond yours. So now there's coordinating between incident response teams, there's all that stuff. And so you did all of this simply by doing a surface analysis of all of the files in that malware that you got. And that's the point of the exercise. You didn't have to run anything. You didn't have to do much. You could simply look at the files, binary, let me look at the strings. Oh, here's a path name. Tell me about this program. Oh, it runs as root. So even doing the simplest things with a piece of malware gives you a huge quantity of information. And then you can summarize that using some of the programs to do that. Okay? So that's what the malware analysis is. And if you took this, now you do really well. But it takes about 3 hours in the afternoon, on Wednesday afternoon of the 5-day course, for the students working in teams to go through this and go. And of course, you got this cards.asc file with Julio Martinez. Who's that? Who's Julio? It's Julio's fault. He's the person who broke in. Could be, but is there any connection from what you've seen between Julio and this activity, other than the fact that they were files in the same directory? So there's some red herrings in there, which makes it fun. So now you've just done malware analysis of a whole bunch of files in a Unix environment. So what do you think of that? It's pretty easy to do. I mean, file, strings, you can do a lot of stuff with that.
And just the reason that class, do they get to do this on a virtual environment?
No, they do it with paper. They ask for a question, we give them a piece of paper that's got the answer. Because then we can take this exercise anywhere in the world, and all we need is our set of paper and files. And that's how we've done it. We've done it over in the Middle East, we've done it in Far East, and it works just as well because they're asking questions and we're giving them paper. So with that, thank you for staying. I'm done. I'll answer any questions